In this tutorial, we're going to take a look at 4 examples of solving systems of equations, linear equations by graphing. And so, and those will all be 2 equations. We won't be getting into any 3 or 4 or past that. So the first one here, both lines are given in y equals mx plus b form, so that's probably the most convenient way to graph them. So let's start with the y equals 2x minus 6 one. The slope would be 2, and the y-intercept would be negative 6. Now when the slope is an integer or a whole number, remember that the denominator is automatically 1. So if the y-intercept is negative 6, we'll put a point right here to start. And if the slope is 2 over 1, remember the 2 is the rise, the run is the 1. So we go up 2 and to the right 1, and there'd be another point there. Up 2 to the right 1, there'd be another point there. And of course you could keep on doing that to draw your line. So let's label the line 2. So for the y equals negative 3/4 x plus 5, the slope would be the negative 3/4, and the 5 would be the y-intercept. So we'll start by putting a point at 5. Now there's 2 ways you can think of this negative slope here. So we could put the negative up top, which is the normal way it's often done, or we can, if it's convenient, put the negative with the 4 in the denominator. They're not both negative. One is negative, not both of them. Remember, if you divide 2 negatives, if you thought it was negative 3 over negative 4, that would actually be a positive 3/4 slope. So only one of the numbers is negative. So I'm going to use this one with 3 being negative. So from my 5 here, I would count down 3 and then over 1, 2, 3, 4. So there's going to be a point right there. If I wanted to go down 3 and to the right 4, there would be another point right there. Now this one here isn't too practical for the graph I have here, but it would mean that we could, for example, go up 3, and then since the 4 is negative, you could go left 4, and you can of course tell that there's a point right here. If we extend the line, we'll go through that. And let's label the line with its equation. Now we're looking for where the 2 lines cross or intersect, and that's this point here. So it's the point over 4 up 2, which we would call the point 4, 2. You can also state the solution as x equals 4, y equals 2. That's just as good. Example number 2. So here are our lines, y equals x plus 1 and y equals 3x minus 3. So for the y equals x plus 1 line, there's a coefficient of 1 here by the x, so the slope would be 1. And just like on the previous page, if it's a whole number, the denominator is automatically 1. So the y-intercept is at 1, so we'll start by putting a point right here. That's where it crosses the y-axis. And if the slope is 1 over 1, I go up 1 to the right 1. There's a point, up 1 to the right 1. There's a point, and I, of course, could keep on going. There's my y equals x plus 1 line. Now for this one, the slope would be this 3, and the y-intercept is negative 3. So once again, whole number slope, so denominator of 1. So we'll start with putting a point here at negative 3 on the y-axis. And if the slope is 3, that means from here, if we go up 3 to the right 1, that's another point. And we could go up 3 to the right 1, that's another point. So that must be the point where they cross. And so let's label our line. So the point of intersection is 2, 3, over 2, up 3. So 2 comma 3 is the intersection point. Or we could say x equals 2, y equals 3. Question number 3. Now the first line isn't in y equals mx plus b form. It's kind of close to standard form, but not quite. So we're going to rearrange it into y equals mx plus b form. The second one is in that form, so we can just use the slope and the y-intercept for that one. So let's start by writing this one down. Now, in order to put this in y equals mx plus b form, the first thing I want to do is isolate the y term. Get the negative 5y alone on one side. So I want to get rid of the 4x. The 4x is a positive 4x term, so the opposite thing to do is to take away 4x on both sides. If I subtract 4x from this 4x, there's going to be no x's here. Now subtracting 4x is the same as adding negative 4x. I could put the minus 4x after the 20, but I'm trying to write it in the same form as y equals mx plus b. See, it has the x term and then the number afterwards. So that's why I wrote the negative 4x there. Now these, the purpose of doing the subtract 4x is those add to 0. So I would now have negative 5y equals negative 4x plus 20. And now that I have the y term alone, I want to get y alone. So I want to get rid of that negative 5. The negative 5 is multiplied by the y. So the opposite of multiplying by negative 5 is to divide by negative 5. So we'll divide both sides by negative 5, all the terms. And of course the purpose of doing that over here is negative 5 divides into negative 5 going exactly once. So this is going to be a 1y here. The slope is going to be 4/5. Two negatives divide to give you a positive. So this is 4/5 x, and 20 divided by negative 5 is negative 4. So this is the slope, and the y-intercept would be the negative 4. So we'll start by putting a negative 4 here. And if the slope is 4/5, if we start from here and go up 1, 2, 3, 4, and then over 2, 3, 4, 5, that's another point on the line. So we can draw a line through those. So that's the y equals 4/5 x minus 4 line. So the second one here, the y equals negative 2x plus 10. Negative 2 would be the slope. The y-intercept's 10. And integer slope again. So remember, there is a denominator of 1 for this. So starting by putting a point here at 10 on the y-axis, and the slope is negative 2 over 1. So down 2 to the right 1. Down 2 to the right 1. So do that for a few points and you can draw your line. So that's the y equals negative 2x plus 10 line. And this is where they cross, so the solution would be the point 5, 0, or we could say x equals 5, y equals 0. Last question, and notice that both of these lines are not in y equals mx plus b form, so we're going to rearrange both of them into the slope y-intercept form. So let's start with the red one first here. Now the first thing I would think to do is I'm going to get rid of this x term, and I guess you could do the 4 first. That would be okay, but ultimately we want the y term alone on the left. So I'm going to get rid of the 3x. Now the 3x is positive, so to get rid of it I would take away 3x from both sides. And I could also have written negative 3x plus 0 here. That would accomplish the same thing, but I can just subtract 3x from 0. That's fine. So these 3x's, 3x minus 3x is nothing. So that's going to be 0. So we would just have negative y plus 4 equals negative 3x. Now the next thing I want to do is get rid of this 4. So I have the negative y term alone. I want to isolate the negative y term. So the opposite of adding 4 would be to take away 4 from both sides, so I'll do that. And of course the purpose is so that those 4's are gone. There's no numbers on the left at all. So now I'll have negative y equals the negative 3x minus 4. Now I've got negative y isolated. I want it to be a y. So that's the same as negative 1y. So the negative 1 is multiplied by the y. So the opposite of multiplying by negative 1 would be to divide by negative 1. So I'm going to divide all the terms by negative 1. And the purpose of that is so that this negative 1 divides out with, this is really a negative 1 here. So this is just going to be a y on the left. And negative 3x divided by negative 1. Negative 3 divided by negative 1 is positive 3. And negative 4 divided by negative 1 is positive 4. So the slope would be 3 and the y-intercept would be 4. And another whole number here, so again, same as having a denominator of 1. So let's start by putting a dot here at 4 on the y-axis, and the slope is 3. Now 1, 2, 3 over 1, there would be a point right there. There's a better way to write that because I'm so high up in the graph. So 3 over 1 is the same as negative 3 over negative 1. If I multiply top and bottom by a negative 1, then I change my 3 over 1 to negative 3 over negative 1. So I can also see the negative 3 would mean that we would go down 3, and the negative 1 would mean we would go, after going down 3, we would go left 1. So it'd be a point right there. 1, 2, 3 over 1, there's another point there. So there's my line. There's a couple points to graph, and of course that's the equation right there, y equals 3x plus 4. So now let's do the blue one here. So I want to isolate the 5y term, so let's get rid of the 7x and the 2. So I'll get rid of the 7x first, so I'm going to subtract 7x from both sides. And of course the purpose of that is 7x minus 7x is nothing, so there's no x terms left here on the left side at all. So now I would have 5y plus 2 equals negative 7x. And now I want to get the 5y term alone, so I want to get rid of the 2. So the 2 is added to the 5y. So the opposite of adding 2 is to take away 2. And of course, the 2 minus 2 is nothing, is 0. So they subtract to 0. So I now have 5y equals the negative 7x minus 2. And the y term is multiplied by 5. So I'm going to divide out this 5 like this to isolate the y. So I'll just have y here equals, and this would be negative 7/5 x minus 2/5. Now, the negative 7/5 is the slope. The y-intercept would be negative 2/5 or negative 0.4. This example still solves by graphing, but it's actually a little bit of an example about how graphing isn't the best way to solve always, because when you get into graphing like y-intercepts that are decimals or fractions, it becomes a little bit more challenging. So there are limits to how good graphing is as a method for solving systems equations, but bear with me, we'll be okay. So negative 0.4, see this is 0, this would be negative 1, so negative 0.4 is just a little bit above the negative 1/2 here. So we'll put a dot about right there. And of course that dot's pretty big, it covers a large area. The slope is negative 7/5, so from there I'll go down 1, 2, 3, 4, 5, 6, 7, and then over 5. 1, 2, 3, 4, 5. And I'll put a dot right there. And of course, I could put more dots if I wanted to, but especially when the dots are fairly far apart, it's a fairly accurate graph. So I want to know where they intersect. They intersect at this negative 1, 1 point. So that would be my solution. Or I could say x equals negative 1, y equals positive 1. And that's the end of the tutorial.